Hi everyone, welcome back to our channel. Today we're exploring Josephus problem, a classic challenge in computer science with historical roots. So with this approach, we will try to solve this problem, find the winner of the circular game. The Josephus problem is named after a Jewish Josephus who described a scenario during the Roman war where he and 40 soldiers trapped in a cave decided to form a circle, eliminate every eighth person until only one remained. So Josephus wanted to survive, figured out where to sit to be the last one in standing. So basically, this problem where we want to find the winner of the circular game, so we will try to use this particular mathematical formula here, which is j of n comma k equal to j of n minus 1 comma k plus k modulus n. So this formula will give the kth person being eliminated. So that will be the last person, like, or in our case, is the winner of the circular game. So let me give you an example here, right? So let's walk through an example with n equal to 5 and k equal to 2, right? So start with five people, one, two, three, four, five. Eliminate every second person. So if you eliminate second, it is one, three, four, five. Eliminate four, then one, three, five. Eliminate one, three, five. Eliminate five, then three. So the last remaining person will be three in this particular walkthrough, right? So we'll try to see a couple of approaches and able to first we'll go through the normal approach, then we will see how we can optimize and we'll get the time and space complexity. Let's dive into the actual solution in C sharp. Okay, let's start and we can see how we can solve this particular problem in C sharp. So first of all, I want to create a list which holds the friends info, right? It means it should be list of int, and let's say it's friends list, new list of int, and let's swap into n I plus plus friend list dot add I, right? So basically, I'm just trying to create a memory with all the friends information to use to remove, right? So I think it has to be one because it is indexing like one, two, three, four, right? So that's why it will start with one. Then I will try to get the index as zero. I'll start with that. Then what is the while loop here, right? So as long as there is a friend list, because we need the last one, so that means as long as the list greater than one, right? I will try to get the index, like index, and what is the k here? The k is like how many persons, like what is the person count after which we can remove, right? So that k, right? That is a k here. Then minus one with the modulus, the friend list dot count, right? So this will give the index. So where I can use friend list dot remove at and index. Then the friend list will have only one item, and that will be the winner, right? So what we are doing here, like we are creating the list of friends, then we are storing the information to friend list, then we create the index variable, and while as long as the friend list greater than count greater than one, we are getting the index. So this is the index plus how many, what is the person, like after which person we can remove the person, right? So that is k. Then we are doing the modulus for with the friend list count. So then what we are doing with the index, so the remove at is the c sharp functionality where we can remove the particular object from the array, in this case it's list, so that will give the means that will remove from the friend list, so this will have the final value. So let's see. Okay, spelling mistake. Sorry, it's my bad. So any guesses with the time and space complexity here? So I'm missing something with remove at, so let me check that. Okay, I think something wrong with initial approach. But yeah, so this is how we can do it to get the final winner, right? So any guesses with the time and space complexity here? So because it is we are looping through one and we are looping through up to n minus one, right? So it is looping through n and n minus one because there will be one winner. So it has to loop through n minus one times. Uh, then it will be, I think it will be order of n and n minus one. So it will be order of n square is the time complexity, and the space complexity because we are storing information. So it's order of n, right? So in my opinion, it will be order of n into n minus one and order of n to store the information, right? So because we are taking the extra storage here, so let's see how we can optimize this particular solution. Okay. Okay, let's try to optimize this solution without using any memory, and the time complexity also we try to reduce, right? So let me start with the problem uh, statement and solution, right? So basically what we are trying to do is, right, so there n people stand in a circle starting from the first person. You can count and eliminate the every kth person, right, until the only one person remains, so that he will be the kind of he or she will be the winner, right? So the challenge is kind of determine the position of the last remaining person, right? So let's say we want to get the winner index, right? So I'll just try to initiate winner here as 0 with the base case of one person, right? So that is more of one person. Then we will try to loop why I equal to 2, right? So let me explain that, like why I am starting my index of I as 2, right? Because loop means we need to start, at least there should be a two persons, right? Like otherwise, so it will be kind of 0 because we need to start from the minimum, like I equal to 2, correct? Then the winner will be winner plus k, means k is how many persons, like what is the count we need to do to get to remove the person, right? K, the kth person. So then we'll do the modulus that will give the winner. Then we will do the winner plus one. Why we will do the plus one? Because we need to do the zero based indexing to one based indexing to get the final winner, right? So let's see whether this will run or not. So I think it is successful. So what do you think about time and space complexity here? So because we are looping through only one time here, so it will be order of n, and also we're not storing any extra storage or extra information here. So the space complexity is order of 1. So we came from order of n square and order of n to order of n and order of 1, right? So as you can see, we started with the int winner 0 and we loop through I equal to 2. Because why I equal to 2? Because the problem statement typically begins with counting from the second person, right? Because it's a one based indexing scenario, so the base statement will start from the two persons. So there will be one winner when one person is removed, right? So that is the reason the I equal to 2. So that should be remembered. Like it's not I equal to 2 0, it's I equal to 2 because as per the problem statement, the second person will be removed, then there will be one winner with the one based indexing. So then this is the formula where we'll get the winner with the winner plus 1, and then it'll the modulus will give the final result. So if you take the positions here, right? So let's say if I equal to 2, then it's 0 plus 2 modulus 2, then winner is 0. So when I equal to, let's say, 5, it will be 0 plus 2 modulus 5 equal to 2, right? So sorry, it's plus 0 plus 2 modulus 5 equal to 2. So then it because it's a one, we need to get the answer is one index, so this will be the third person, that will be the kind of the final answer we'll get here. So that is the approach with what we can get is more of the time complexity order of n and the space is order of 1, right? I hope this helpful. So I think we can start with initial approach where get the index with some calculation and remove it, but it will take more space and more time. So this is kind of the other approach where the problem statements we need to read it carefully to get the right initial index, and now we can calculate the winner. So these are typical problems where we need to understand the background to get the final solution. I hope this is helpful. Thank you.